Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss linear inequalities. Linear inequalities. In your earlier classes, you have studied linear equations in one variable and two variables also. You have solved the linear equations in one variable as well as you have drawn the graph of a linear equation in one variable and two variables also. Okay, my dear children. Now in this class, we are going to discuss linear inequalities. In this chapter, exercise 6.1 concepts. We are discussing now exercise 6.1 concepts. Before going to start the concepts of exercise 6.1, let us know what are the inequality signs. These are the inequality signs. See this one, this is greater than. This sign denotes greater than. The second one, greater than or equal to. See here, greater than, a line is there under the greater than symbol, a line is there, so this sign denotes greater than or equal to. Okay, my dear children, right. Third one, this is not less than. This inequality sign is called not less than. Here second inequality sign and third inequality sign gives the same meaning. Here second and third inequality signs give the same meaning. Means greater than or equal to or not less than. Both inequality signs give the same meaning. Denote the same. Okay, my dear children. Right. Now come to the fourth inequality sign, less than. This inequality sign is called less than. Next, fifth inequality sign, less than or equal to. Under the less than symbol, here a line is drawn. So this is called less than or equal to sign. Okay, my children. Now come to the sixth inequality sign. See here, greater than symbol and it is striked out. So it is called not greater than. Not greater than. Here, fifth one and sixth one denote the same inequality sign. Gives the same meaning. Okay, my dear children. Right. Come to the seventh one. Not is equal to sign and it is striked out. So it is called not equal to sign. And the eighth one. See here it is greater than or equal to. In the word Psalms, at least, if the word is given at least, then you have to use greater than or equal to sign. For example, you have to get at least 40 marks. At least 40 marks per 100 means we should get at least 40 or more than 40 marks. Okay, my children. Similarly, last one, ninth one. In the word sums, in the word problems, at most, if the word given at most, then we have to use less than or equal to. For example, a man can walk at most 10 kilometers in a day. A man can walk at most 10 kilometers in a day. Means he can walk less than or equal to 10 kilometers. Understood, my dear children? These are all inequality signs. Okay, my dear children? Right. Now come to the second point, the next point, that is inequality. What is meant by inequality? Two real numbers or two algebraic expressions related by, they are connected by either two real numbers or any two algebraic expressions are connected by the symbol less than, greater than, less than or equal to, or greater than or equal to. By any one of these four inequality signs form an inequality. The mathematical statement is said to be inequality. Understood this point, my dear children? Right. Example: 3 less than 5. 7 is greater than or equal to 5. Or the examples of numerical inequalities. If you observe these mathematical inequalities, mathematical statements, here no variable is there, only numerical values. By using the numerical values, we have written one inequality. This is another inequality. Understood this point, my dear children? Right. Now come to this point. X less than 5, y greater than 2. X is greater than or equal to 3, y is less than or equal to 4. If you observe these inequalities, here one variable, right side is one numerical value. In all these cases, in all these inequalities, variable is there. So these inequalities are the examples of literal inequalities. Understood this point, my children? In the inequality, if any variable is given, x, y, z, any letters, English letters, then the inequality is said to be literal inequality. Understood this point, my children? Right. Now come to this line. 3 less than 5 less than 7. But we read this inequality as 5 is greater than 3, 5 is greater than 3 and less than 7. Understood this point, my children? We read this symbol, we read this mathematical statement, we read this inequality as 5 is greater than 3 and less than 7. Understood this point, my dear children? We have to start the sentence with this middle number. Okay, my dear children? Similarly, see this inequality 3 less than or equal to x less than 5. But we read this inequality as x is greater than or equal to 3 and less than 5. Okay, my dear children? Understood how to read an inequality? These inequalities are said to be double inequality. If you observe these inequalities, two inequality signs are used here. Here also we use two inequality signs. So these are said to be double inequality. Understood this point, my dear children? Right. Now come to the next point, that is a third point. These are some examples of inequalities. Observe these inequalities, my dear children. Ax plus b less than 0. Let us consider this is the first inequality. Ax plus b is greater than 0. Let us consider this is the second inequality. Ax plus b less than or equal to 0. Let us consider this is third inequality. Ax plus b greater than or equal to 0. Let us consider this fourth inequality. X plus by less than c. Let us consider this is the fifth inequality. X plus by greater than c. Let us consider this is the sixth inequality. Ax plus by less than or equal to c. Let us consider this is the seventh inequality. Ax plus by greater than or equal to c. Let us consider this is the eighth inequality. Ax square plus bx plus c less than or equal to 0. Let us consider this is the ninth inequality. And finally, ax square plus bx plus c greater than 0. Let us consider this is the 10th inequality. We categorize these inequalities into two types. What are the two types? See these three lines, my dear children. Here, first inequality, second inequality, fifth inequality, sixth and 10th. If we observe these inequalities, only less than or greater than, only these symbols are used here to write this inequality. Either less than symbol or greater than symbol are used. So these are said to be strict inequalities. Okay, my dear children. The remaining inequalities, that is third inequality, fourth inequality, seventh inequality, eighth inequality, and ninth inequality. If you observe these inequalities, they used less than or equal to, less than or equal to, or greater than or equal to. That is why these inequalities are called slack inequality. Slack inequality. Understood this point, my dear children? Right. Inequalities. Inequalities from 1 to 4 are linear inequalities in one variable x when a is not equal to 0. If we observe the above 10 inequalities, from inequality 1 to 4 are said to be inequalities, linear inequalities in one variable x when a is not equal to 0. Means the coefficient of x should not be equal to 0. While, understood this point, my children? Right. While inequalities from 5 to 8, in the above list of inequalities, from a fifth to eighth inequalities, they are linear inequalities in two variables x and y when a is not equal to 0, b is not equal to 0. Understood this point, my dear children? If you observe the inequalities from fifth to eighth, they are also said to be linear inequalities. Linear means the degree of the variable should be 1. If you observe the inequalities from 5th to 8th, x power is 1, y power is also 1, exponent of x is 1 and exponent of y is also 1. So they are said to be linear inequalities in two variables because two variables are there, namely x and y. When a is not equal to 0, b is not equal to 0, means x coefficient of x should not be equal to 0 and coefficient of y also should not be equal to 0. In that case, the equalities from 5th to 8th are said to be linear inequalities in two variables. Understood this point, my children? Right. Now come to this point. Inequalities from 9th and 10th. The last two inequalities, if you observe the last two inequalities in the above list, are quadratic inequality in one variable x. If you observe the inequality algebraic expression, it is a quadratic expression in x. Isn't it or not, my dear children? So it is said to be quadratic inequality in one variable x when a is not equal to 0, means coefficient of x square should not be equal to 0. Understood this point, my children? Right. Note, in this chapter we study linear inequalities in one and two variables only. Okay, my children? Understood? Right. Now come to the next point, that is solution of an inequality in one variable. What is the solution of an inequality in one variable? Any solution of an inequality, any solution of an inequality in one variable is a value of the variable which makes it a true statement. Understood this point, my children? The value of the variable should make the statement true. That value is said to be solution of the inequality. For example, take this example. Solve x less than 5 when x is a natural number. Understood this point, my children? We have to solve this inequality when x is a natural number. Then what is the solution said? 1, 2, 3, 4. 1 less than 5. Isn't it not, my dear children? True statement or false? Yes, true statement. 2 less than 5 is a true statement or not? Yes, it is a true statement. 3 less than 5 is a true statement or not? Yes, it is a true statement. 4 less than 5. It is a true statement. So all these values make this inequality a true statement. That is why these are said to be solution set of the inequality. Understood this point, my children? Understood this example? Right. Now come to the next example. Solve x less than 5 when x is an integer. See this second example. I have taken the same inequality, but condition is different. What is the condition here? X is an integer. Understood this point, my dear children? Here also x less than 5. Here also x less than 5. But the condition is different. Here x is a natural number, whereas here x is an integer. In this case, the solution set is and so on, -3, -2, -1, 0, 1, 2, 3, 4. All these values make this inequality a true statement or not? Yes. All these values, all these values make this inequality a true statement. That is why these all the numbers said to be set of solution. Set solution set of the given inequality. So infinitely many solutions are there for this inequality. Understood this example, my dear children? Right. Now come to the third example. Solve x less than 5. See here this example also, my dear children, observe here. This is also same inequality. I have taken same inequality, but condition is different. When x is a real number, when x is a real number, then the solution set is open interval minus infinity comma 5. All the real numbers less than 5. This is the solution set of the inequality. Understood this example, my dear children? Right. Now come to the next point. That is fifth point. In earlier class, you have learnt the rules for solving a linear equation. In solving a linear equation, you have added the same number on both sides. You have subtracted a number from both sides of the equation. Similarly, you multiplied the equation on both sides by a same number. Similarly, we divided on both sides by any real number. Okay, my children. Similarly, here there are the rules to solve a linear equation. Similarly, here some rules are there. In solving an inequality, we have to follow these rules. These are also same as that of the rules what we followed in solving a linear equation. Okay, my children. See the first rule. Equal numbers may be added or subtracted from both sides of an inequality without affecting the sign of inequality. Understood this point, my children? It means we can add the same number on both sides, or we can subtract the same number from both sides of the inequality. Then the inequality sign does not change. Understood this point, my children? Right. Come to the second rule, rule number 2. Both sides of an inequality can be multiplied or divided by the same positive number. Observe this point, my children. We can multiply on both sides of the inequality by a positive number. Then the inequality sign does not change. But see this point, my children, concentrate here. But when both sides are multiplied or divided by a negative number, if we multiply on both sides of the inequality by a negative number, then the sign of the inequality is reversed. It means if you multiply on both sides of the an inequality, then greater than sign changes to less than sign changes to greater than in the next step. Understood this point, my children? For example, see here minus 2x is greater than 5. This is the inequality. Here I multiplied on both sides of this inequality by -1. Then what you get here in LHS? 2x. If you multiply by minus 1, what do you get here? 2x in LHS. Here see that greater than sign is there. It is reversed as less than. Understood this point, my children? If you multiply by minus 1, what we get here? Minus 5. So by multiplying on both sides by minus 1, we get this step. Understood this example, my dear children? Please remember this point, my dear children, in solving an inequality. Understood this point, my dear children? Right. Now come to the third rule. Rule number 3. If we take reciprocal or multiplicative inverse of both sides of the inequality, then the sign of inequality is reversed. Understood this point, my dear children? If you take reciprocal of both sides of the inequality or multiplicative inverse of both sides of the inequality, then also the sign of inequality is reversed. See this example, 5 by x greater than 2 by 3. Okay, my dear children, this is the given inequality. I have taken reciprocal of this LHS. What is the reciprocal of this LHS? X by 5. See here, this is inequality sign is reversed. Here a greater than sign is there. It is changed into less than. Here also I have taken its reciprocal. What is the reciprocal of this number? 3 by 2. Understood this example, my dear children? I have taken reciprocals of the both sides of this inequality. In this case also, sign of inequality is reversed. Okay, my dear children? Understood this point? Right. You should remember these 3 rules when you are solving the inequalities. Understood this point, my dear children? Right. Note, henceforth, unless stated otherwise, we shall solve the inequalities in this chapter in the set of real numbers. In the previous examples, I have taken x is a natural number, x is an integer, x is a real number. Like this, I have taken some examples. But here, in this chapter, we take a set of real numbers as a solution set. In that set of real numbers, which values are satisfying the given inequalities, that the set of real numbers is called solution of the given inequality. Understood this point, my children? Right.